Good morning, everyone. Just to begin with, as usual, I'll get a couple of you to let me know that you hear me through the chat line. That would be good. Okay. Thanks, Clive and Daniel and Lucas. Good enough. Just want to make sure that you're hearing me and I don't have a problem with my audio channel. Okay. Like before, we'll be working on questions, end of chapter problems and supplementary problems for the most part of our lecture of 2 hours today. What I will do is make a few sort of announcements, if you will, as we go on here. I will open the quiz number 2 for review today at we'll say 11:30 this morning, and I'll leave it open for about a half an hour. And if you want to make a note of that, I'll send out a quick email on that as well, perhaps right at the conclusion of our talk here today, just so you have that in writing as well or in email format. Quiz 3 on Chapter 3 will be next Monday. That'll be March the 15th. And I'll send out an email to that effect. And your midterm will be on March the 22nd. That will involve chapters 1, 2, and 3. We will conclude chapter 3 today in all likelihood. And again, much of the task is lying with you to do that by studying the theory and then by applying the application of the formulas in this chapter for chapter 3, and we'll further work problems along the way. So again, I'll send out a separate email on all of those counts. I tend to send out separate ones and not combine them, so nothing gets lost in the middle. So I'll send out 3 emails: one for review of quiz 2, one to notify of chapter 3, quiz 3, if you will, and then the midterm on the dates that I gave there. Next Monday, we are probably going to be starting, we will be starting chapter 4 as well. I also should have mentioned the meeting's being recorded. I sometimes forget to do that, but it's been recording now for 3 minutes and a bit. Just so you're aware of that. And what else? Yeah.
What are the start times for the quiz and the midterm? Is it 1 o'clock again?
Yeah, I'll put that in the email, but yes, that's correct, Kelly. Most of my quizzes will probably start at that time, especially if we're having a lecture that morning. I'll usually give a couple of hours for people to have lunch and then come back and do the quiz. So that's how we'll set that up. The midterm are calculations. I see that coming in from B. Oops, sorry, you sent that privately, but I apologize for that. But I will, the midterm will be mostly calculations, maybe all calculations, probably about 8 or 9 questions, possibly 10, depending upon the degree of difficulty they are. You won't have a lot of slack time in the 2 hours. It'll probably fill up the 2 hours pretty much with not too much time left over. So don't kind of belabor one question if you're not sort of working towards a good answer or knowing how to handle it. Move on to the next question so you get as many done as possible in the event that you do have to stumble. Correct, the midterm it covers chapters 1, 2, and 3. It'll be on Learn in a sense that I will give you the exam, the midterm exam, through the quiz toolbox. However, the work will be on paper in front of you on your desk, And from that, you will then scan it and submit it into a Dropbox dedicated for that particular exam, midterm exam. So that's how, in general, it'll be handled. So try to make sure all of your tools are set up and good to go in 2 weeks for that midterm. We'll go from there. As I mentioned before, if you don't have a scanner or you don't have a scanner that's working, you could take pictures of your work. Try to take the pictures in the order of the questions. It just makes it easier for me to mark, so I don't have to bounce around all over as I'm doing them. And don't embed your answers into the if you have to email it to me, hopefully you don't, you can put it into a Dropbox, but if you have to email it to me for one reason or another, don't embed your questions into the main body of the email. Put it into an attachment and then send the attachment. That just gives me more success, if you will. I've experienced quite a bit of difficulties to some degree or another when people just simply embed that read into the body of the email. And then when I open up the email and print it for hand marking, I get your work is cut off, truncated. It doesn't always go as far left or far to the far or downward. It ends up with partial showing of your work for some reason. So don't embed it into the main body of the email. Do it as an attachment. Okay. And yeah, that gives you that overview there. So I'd like to just check on my notes here. There'll be no class on the 29th of March. You're probably somewhat aware of that, but that's Easter Monday, and the college is typically closed for Good Friday and Easter Monday. So you should be aware of that. I'll be mentioning that so that people aren't trying to sign in on that Monday morning, because there probably won't be very many other people in the mix at that time. It just simply won't be a class on the 29th. And I've also noticed that some people are looking at the course outline and looking at schedules in there. That's a general guideline. Don't pay a lot of attention to that. I will give you at least 1 week's notice on all upcoming events. That'll be in the form of an email. And I think, and I'll also mention it in the class discussions that we're having like now. So you don't get too concerned over the fact that all of the quizzes, especially and the midterm exam, do not fall on the day that's given there. We need to have flexibility on that depending upon how well we're moving along in the course. So if you need confirmation of that, send me an email, but I've been getting a handful of them at least along that line that you're not sure if there's a quiz or not, like for today. So again, just because the course outline says there's one scheduled for today, that's sort of a perfect fit. If everything's going to flow well, it would work out, but that hardly never happens. There's always situations where we fall behind a little bit, or in some cases might even get ahead. But just pay attention to your emails that come in and to the verbal discussion, if you will, such as what we're having right now, which will clearly identify the schedule for your quizzes and exams, and it won't be long before assignment number 1 will be put before you as well. So that's what we have. Is Easter Monday on the 5th? Did I make a mistake there? If it is, that'll be the day. So whatever Easter Monday is, I apologize for that. I thought I looked it up correctly, but I may have missed it. So thanks for correcting that if it's on the 5th, and I will make sure of that to begin with so that I'm here on the 29th now and won't be here on the 5th. But thanks, B, for that point. Okay. I'd like to turn our attention now to working some problems that are so I'm going to switch over to my document camera. Hopefully you can see that. Just give me a minute here before I find it. Okay, you should be able to see on your screen now my graph paper. Just let me bring up my chat line again, please. Okay. So it looks like you can see it again. Once again, as I tend to go through these things, I'll speak to it in the negative. If you cannot see the graph paper right now, then please let me know in the chat line. Otherwise, I'll assume everyone has a view of it. So the question I want to start out with today will be end of chapter 3.20. And if you'd like to open up that question in your book, some of you hopefully have already done these questions. And just let me find it here. You've probably recognized by now in the course textbook that there's a small close-up, I think it is, in there that deals with linear interpolation. So if you're using linear interpolation, there's a procedure I will want you to follow. And what we'll do is work a question. 3.20 is exactly that. It's a question that requires a solution by linear interpolation. Appreciate that's exactly what it is. It's an interpolation. It is not an extrapolation. It is an interpolation. And also appreciate that it is an approximation. So when using linear interpolation, it'll give you a pretty good answer. It may not be bang on, but it'll give you a pretty good answer, because what you're doing is taking a linear function, a straight line, a linear function, and you're trying to fit that over a nonlinear or a curve function. And there's a good diagram in the textbook that sort of accents that point that I just made. So you should be familiar with that. It doesn't come into play too much at this stage, but in chapter 5, when we're dealing with the internal rate of return method, it's pretty big as an application. So you want to be comfortable with using linear interpolation, especially when we move into chapter 5. But we will have a couple of problems, and there could be one on the exam that deals with this as well. That's all fair game. So with question 320 here, we're talking about Trenny. She has one of her assistants prepare a cost estimate. She's already done a couple involving 2 different sizes of power plant. In other words, measuring the size of the power plant by the number of megawatts it will produce and the corresponding cost. So the difference here is how do you do, how can you use that information as a way of determining the cost of something that produces a either a certain power plant capability with a different amount of money, or you could work it in reverse, or in that you could say how much money would something producing a certain megawatt would produce would cost. So let's take a look at this question here. Just bear with me here as I look for my tools. Okay. So this is EOC 320. And in this particular case, we have from the information given, a graph. When doing linear interpolation, I will request that you show the diagram of the linear interpolation, and that's normally set aside as 1 mark if you show that correctly. So it has an x-axis and a y-axis. So the x-axis could look something like this, and the y-axis something like this. And the value you're looking for should be placed on the x-axis. And in this case, we're looking for how much, given a certain amount of money, how much megawatts would we be, what kind of plant would produce. That's not well worded, so I'm going to back up on it a little bit there. You're looking for, if you have $300,000, what kind of plant in terms of megawatt power could you achieve with that amount of money? So what we know here is that for X1 here, we know that we have a 100 megawatt power plant, and the corresponding value for that would be Y1, and it has a value of $200 million. We also know here that we have another opportunity here of X2. These are the two that Trene's assistant has worked out as to what you could get. And this one here would produce a 200 megawatt power plant. And the corresponding cost for that would be $360 million. So I'm just going to conclude the diagram by putting this in here. These two are correlated. They're a pair of values. And the same thing here. Another pair of values. The 200 megawatt will cost 360 million. The 100 megawatt will cost 200 million. After Trene reviews her assistant's work as to the cost to generate these two plants measured in terms of megawatt power, she indicates to her assistant, but we only have $300,000. So that will become, this is Y2 here, that will become Y star. This one here will be how much money she actually has. She only has 300 million. She does not have 300 million there. So the question would be then is, if that's the case, this will be X star. That's what we're looking for. So the general rules that I tend to use is the value you're seeking should go on the x-axis, so there'll be a missing number there, the question mark, that's what you're looking for. And on the y-axis would be the corresponding information you have related to x1, x2, and half of, or the y component of, that goes with x, with the x value here. So in order to set that up, there's an equation in the back of the textbook that you should use. And that equation here would be what is X star. So it's going to allow us to calculate it directly. X star will be equal to X1 plus X2 minus X1 onto y star minus y1, y2 minus y1. You could put that in brackets if you want, not a big deal. It's self-explanatory what you're doing there, but certainly if you feel it's necessary, by all means. And I think it might, I'm not sure how it is in the textbook, but either way, you can leave it open of brackets or include it in brackets. So we put the values in here. So X1 is 100 megawatts right here, plus X2, which would be 200 megawatts minus 100 megawatts, X1. Make sure you note these are in brackets in that from an arithmetic operation perspective. That'll have to be done first, if you will, before you add it, or to this one over here. I've seen people kind of add these three numbers up. Not a good idea. Over here with the fraction, Y star is the amount of money that you have available. And Y1 is the amount of money that you were able to calculate what in relation to the corresponding megawatt power. So that'll be minus 200 million. And over here we have Y2, which is 360. Minus, once again, Y1, which is 200 million. So if you want to do the arithmetic of that for me, a lot of zeros there, so it's really not that difficult to calculate. But you should end up then with, I'll break it down a little bit here, 100 megawatt plus 62.5 megawatts equals to 162.5 megawatts of power. So that's the answer we would have here. Not much I can tell you about it. Normally, not normally, but if you're required to do linear interpolation, you would get 1 mark here for the diagram if done correctly. You would get 1 mark for selecting the right formula, and another mark here for putting in the correct values, and then your bottom line calculation of what you have. So just doing that little bit of work, it could be worth 4 marks. Sometimes I only make it worth 3 marks, things of that nature. So I do use some discretion on this aspect of it, but that is what I'd expect. The diagram, the graph, I guess would be a proper term here. The graph is properly set up. Sometimes one of these values can be negative. So your line might, in that case, actually come down here if it were negative. That can occur, and you'd have a minus Y value. You can put it in there, or you could still put it up here. Just don't lose track of your signage when you're putting it into the formulas. That's all. And that would that's how you go about it. So again, the graph for linear interpolation, the prime formula, the values in your bottom line answer is what I'd be looking for in that. You don't need to use color like I do. I tend to do that a little bit to distinguish between what I'm searching for versus what I have to pivot off of for a solution. Okay, on that. Okay, so a couple of you have done the calculations and you've confirmed what I had, and that's I'm hoping not surprising for me because I've done this problem a number of times and pretty well know. I just want to check back. Everybody's coming up with that. Yep, good. Just looking at the chat line here. No, Lucas, I wouldn't use similar triangles. Try to stay with the mathematical formula. If you're good with that, please. That's what I'll be looking for. So although you'd still get a mark for probably arriving at the correct answer, but having said that, you should use this layout. This is what I'd expect to see. It's what the textbook prescribes, and I just want to make sure you know how to use that as a part of the course layout. Once you graduate and are asked to do something of a linear interpolation on your own, that becomes between you and your employer, or if it's your company, it's all about what you want. But for the purpose of this course, please stay with the information that's being presented through the textbook, and hopefully that all corresponds to what I'm presenting to you in the lectures, whether they're asymmetric, asynchronous, or synchronous lectures. Okay on that. So the next one that I'd like to take a look at would be 322. .22. And in this particular case for 3.22, Gwen has just bought some solar panels to power ventilation in her chicken farm. The panels cost $2,000 and will reduce her electric bill by $40 per month. How long will it take her to recoup, or to recover, if you like, her investment in these panels? If she can earn 12% interest on her money, compounded monthly. So once again, with these questions, if I were to put a question of that nature on an exam, I would indicate that your work must include a cash flow diagram. That's typically the phrase I use. Your work must include a cash flow diagram. No matter how many times I say it, I can almost guarantee you there will be people who omit putting the cash flow diagram, and of course you don't get a mark awarded. If I ask for a cash flow diagram, there must be a cash flow diagram, and it must be done correctly and legible to the extent I understand what you're doing. It doesn't have to be all done with rulers and scale, but you do have to be able to make it representative of what we have. I tend to use a ruler, but it's not necessary, especially for the straight lines. You can freehand it if you like. But in this case, what we have here is we're running this for a certain amount of time. In this case, we're actually trying to calculate the time. So we don't know what it is. All we can say it's N. It's the number of compounding periods, N months. That's what the question is asking for. How long will it take? So it's N, how many months will it take in order to recover her investment through her savings. Continuing on here, we know that the initial cash layout, which would be a disbursement of $2,000. That's what we know. And we also know that as a result of that, she's going to have a saving from her electrical bill. In other words, she won't have to pay, we'll say Manitoba Hydro, anywhere near the amount of money. It's going to save her, according to the question, $40 a month. Well, that's ongoing and it's every month. So that would be an annuity. Fits the definition. The same amount, $40, $40, $40, month after month after month. So we have an annuity. I tend to draw my annuities as they do in the textbook. It usually starts at the beginning here to where the annuity begins, and it runs a diagonal line up until you reach the end of the first year. Now, I haven't marked years on here, but I would just show that at a 45-degree angle, and it's going to continue onward. Like this. And what we have here is $40 per month. So a saving is a receipt. Keep that in mind. Anything that comes back into you as a result of the action you're taking is what we will refer to as a receipt. So we have a disbursement here, form of a single amount, one lump sum. Over here, we have an annuity. Every month, as the months go by, will give you $40 savings, a receipt. The question is, how many months will it take to offset this initial investment? And the interest rate that she's using in here, so I'm just going to write this down, the interest rate will be equal to, it's 12% compounded monthly. Okay. So what we have to do now is make sure that our units of work are all in the same level of units. So this is 12%, but that's nominal. It's compounded. But if we apply the compounding to this, we would end up with a sub-period interest rate per month. So we'd have months for the interest. Our savings are per month. So we have compatibility. However, we have to recognize that our solution is also going to be in months. So that's kind of good news. So the first thing is, let's calculate what is IS. I subscript S is going to be equal to R over M is going to be equal to 12%. We can leave it as a percent for now, over the number of months or the number of compounding periods in the year. And there's 12 of them, 12 months in a year. So that means our sub-period interest rate is simply 1%. If you wanted to, depending upon the formulas that we use, we could express that as 0.01. Now, ordinarily, we would say, well, could we use this? Could we use the factor tables to solve our problem? And we cannot do that. Can anybody tell me why we cannot use the factor tables at this point in our studies? Anybody have a comment in the chat line about that? There's no end value. That's exactly right. That's the problem. There's no end value. So if we turn to the tables, well, okay, we're going to find I equal 1%, but then what end value? We have none, so we can't use them. What we're going to have to do then is use the prime formula in lieu of the factor tables. So that's unfortunate, but that's the way it is. So the approach we'll use for this then is to use the series present worth. Now this one can be worked in a couple of ways. I'm just going to work it in one way here. But we could simply say we got to link these two together here and solve for n. So we can say here that the present value would be equal to the annuity multiplied by, I'll put it this way, I tend to work them out this way. What is P if we know A, I, and N, but we don't have an N value. So I'm going to have to take it a bit further and substitute in this value. So it's going to be A onto the prime formula. And the prime formula from the textbook, as well as in the formula tables of formulas, the list of formulas, is going to be 1 plus IS, I'll just call it, I'll put a little s in there, to the power of n minus 1 over IS onto 1 plus IS to the power of n. Make sure this is understood as an n here. So that would be the formula. So that would set it up for us to solve, because we know P, we know A, we know IS. There's only one unknown left, or there's only one value, which is the unknown that we're going to be seeking. So we're going to have to use some algebra here in order to solve that. So I'm going to use, I have to ignore this because we can't use the factors. We've talked about that, and it was expressed that we, it was expressed that we have no n, so we can't turn our attention to the tables and have a quick solution. What we can do, though, is put these values in. We know that P is equal to 2,000. That's our initial layout of money for these solar panels. And it's going to be equal to the annuity, which is $40 per month, onto, and I'll draw this out here, it's going to be 1 plus 0.01 to the power of n, our unknown, minus 1 over 0.01 onto 1 plus 0.01 to the power of n. So again, I'm not sure of if you remember, and whether you've had to use this sort of stuff along the way or not, but we should be able to solve this from our first year algebraic classes that we took, or that you took. So what do we have here? Well, we're going to have to clean this up a little bit here. There's some numbers we can work with, and I'll draw it out a little longer. In your case, if you're comfortable, you can combine some of these steps together. I'll be able to sort through it with no problem and award marks accordingly. So what we could have on the left-hand side here would be 200,000 divided by 40 multiplied by 0.01. And I say that because we can divide both sides by 40, and we can multiply both sides by 0.01. That gives us this. And on the other side, we end up with 1.01 to the power of n minus 1, 1.01, whoops, my mistake there. Where's my little device here? Yeah, I guess we're okay here. I'm sorry. I was thinking of putting them separately, but no, we'll leave them together. To the power of n. On this side, if we do this arithmetic, 2,000 multiplied by 0.01 divided by 40, we should end up with 0.5. And on this side, we can break this out. We can simply say this is equivalent to 1.01 to the power of n over 1.01 to the power of n minus 1 over 1.01 to the power of n. This will go to 1. Numerator, denominator are identical. So we could stretch that out a little bit more if you like, and simply say it is equal to 1 minus 1 over 1.01 to the power of n. So what we can do next here is to subtract from both sides 1. So if we do that, we would have, and at the same time I'm going to move this, so I'm going to take this number here and then I'm going to add to each side 1.0, try that again. I'm going to add to each side 1 over 1.01 to the power of n and put that on the left side, so it'll become positive. And on this side, I'm going to subtract both from this on both sides. So we're going to have 1 minus 0.5 equal to plus 0.5. I can cross multiply this and indicate then that 1.01 to the power of n would be equal to 0. Losing you here. 1. Where am I? 0.05 Okay. Correct myself here. We can leave the 1 on one side here, and what we're going to end up with here, it would be 1 on this side will be equal to 0.5 multiplied by 1.01 power of n. Then we could say here we'll take and divide both sides by 0.5. So we're going to have here 1.01. I'm going to switch these to the opposite sides here so that we end up with our unknown on the left-hand side here. It's going to be equal to 1 over 0.5, which in turn is equal to 2. So that's about as far as we can take it for the moment with regards to just maneuvering things left and right. But now what we can do is we can take the natural log of both sides of these to get this n value out of the exponential and down onto the main line of calculations. And in order to do that, we're going to take the natural log of the left-hand side. So it'll become equal to n onto the natural log of 1.01 equal to the natural log of 2. So n will be equal to the natural log of 2 divided by the natural log of 1.01. And that, if you work out, will be 69.66 months. Now, the last maneuver we can take on this is that we have to recognize it's going to take 69.67 months, but we make the assumption that all of our transactions occur at the end of a interval. So this would have to be rounded up to 70 months before she breaks even, because she won't realize the saving on the last one until the end of the month. So it'll be at the end of the the 69th year, so that'll be, and it'll take 70 months for it to break even for her. And that's because, as I mentioned, her savings are not realized until the end of the month. So it's a bit of a long solution. You should learn how to take a natural log or a log base 10, whichever way you prefer, but the book uses natural logs, so I'm going to stay with that. And you need to learn how to do that on your calculator in order to solve this. Hopefully you can do that, or if not, you should learn how to do that. So that's what I have. I'm not sure, Fabian, when you put that number up there. Okay, I see where you are now. You're here. Yeah, you've divided both sides here to get to here. Okay, I think that's the point you're making to everyone there. I'm just not 100%. Yeah, okay, thank you. Yeah, I lost track of myself going through there too. So that's what we have. Again, cash flow diagram. How would I mark this? If you got your cash flow diagram correct, you get a mark there. In this case, we have to convert to either an effective or a sub-period interest rate. We've done that. That would be worth 1 mark. Here's your prime. Here's your base formula, if you will. Your prime formula is in here. Putting the values in correctly here. And then what I would look for is the correct answer. Now, because there's so much arithmetic involved in here, ordinarily I would not award a mark for that. But in this case, because of that, I would probably, because of the arithmetic involved here, add in 1 extra mark, because it's going to take you time to do it. It's pretty short in terms of time, probably take you a minute and a half or so maybe to sort of, in a slow, methodical way, lay it on your paper, because you don't want to go too fast and end up making a mistake. So there's a bit of work involved here, but probably a little around a minute of work as you work your way through it to get to here. So that question there would be worth 1, 2, 3, 4, 5, 6 marks is what I would have. And I might have a concluding statement, which would make a request for a concluding statement, which would add 1 more mark if it were asked for at that time. So the key to this is understanding your algebra a little bit along the way, especially from here to here. And then also recognizing you have to round up. Now, if this number here, just to make the point, now, if this number here was, it isn't, but if it were 69.09, you would still round up to 70. So you don't follow traditional round off rules. When you're solving for n, always roll the number up, round it up to the next interval in order to properly conclude the question. Because again, it's a matter of, in the diagram, you do not realize this last payment of $40 until the end of that month, the beginning of the 70th month. So don't lose track of that, please. I sometimes will award for this little maneuver in here, just so you understand it. If you were not to do that, you might lose a half a mark out of the full value of the question in here, if that were the case. Because again, you don't realize that last $40 saving in the middle of the month, you realize it at the end of the month. Okay. So the next one that I want to do here is 3.26. And this one can be done in a couple of different ways, but I'll stick to the way that I've worked it out so far and then mention how else it can be solved. But 3.26, take a look at it here. And in this case, I'm going to solve it using linear interpolation as a part of my solution for me. It could be done otherwise, but what I will indicate here is that for 3.26, it's about Rinque, and she just finished her first year at university, and she wants to tour Europe when she graduates in 3 years. So by having a part-time job through the school year and a summer job during the summer, she plans to make regular weekly deposits into a savings account, presumably to save up for that trip. So she's going to be earning interest on her money while she's saving up and waiting for the 3 years to run its course and then make that trip. Her interest rate again is 18%, but it's compounded monthly. There's that word compounded. So it's telling us that this is a nominal interest rate. The 18 is nominal. But first, the cash flow diagram. And it should look something like this. We need to set up our timeline. Everything starts off from there. And we have to make, it's an average of $15 per week is what she's going to put into this. And there are 4 weeks in a month is the assumption that we will make. How many weeks there are in the month? We're going to say there's 4 weeks. So we're going to work this problem at the monthly level because you could try to work it at the weekly level, as one student attempted to do. But if you do that, you're going to have to convert your interest rate to weekly in order to do that. And that's a bit of a circuitous route to follow. It should still work. I have not worked it out that way. I plan to do that because of the inquiry from another student. But I will work this one with the way I have it already laid out. And I will probably on my own time somewhere later over the next few days attempt to solve it weekly as well. But the smart way to do this one is probably by using a monthly route. One reason for that is that your interest rate will be per month when we're done doing the conversion from the nominal to the sub-period interest rate. So let's conclude our diagram here. What's happening is that she, in this case, is going to deposit money in a bank. That's money going out. Putting money in the bank is not it's not a receipt. You're basically giving the bank the money. So the money leaves your pocket and it goes into an account. It is your account, but the bank is using that money. They're further investing it, and in return, they'll give you some interest, but they will invest it again. So it's, in a way, you have given them, not even in a way, factually, you have given them your money for a period of time. So it is a disbursement. It's leaving your pocket. It's leaving your hands. It's not in your wallet. So we'll do that, and we'll set up the annuity here because it is every a month that she's going to be making this deposit. So it's going to be $15 per week, but we're going to say that that is equivalent to $60 per month, 4 times that amount. Because our interest rate here, I, is going to be equal to, where am I here? 18% compounded monthly. It's there, so IS will be equal to the nominal rate over the number of compounding periods in the year, which will be equal to 18% over 12 months in the year, equal to 1.5%. So in this particular case, the reason I converted this from a weekly to a monthly deposit is because, again, the interest rate is at its compounded monthly, and that's what we want to work with. So from that, we could say here, we want to know how much will she have at the end of, and I have to look for this in the question, 3 years. So in 3 years, but again, we're working this at the monthly level. The interest is at monthly level, that's IS. I is equal to monthly. We need to convert this to months as well. And by multiplying the weeks, 4 weeks into a month, we can also work that at the month level. So we're going to have months, months, and months. So this here will be equal to 36 months. So let's work this, and we'll hit a bit of a glitch, but that's where we'll talk about linear interpolation. We're looking for a future value. How much will she have at the end of 3 years? So we're looking for a future value, and we're going to be making monthly deposits of $60 per month. That's what we're going to be doing to make this work. And so we have an annuity, and we have to use what is F. If we know A, the annuity, we know the interest rate, and we know N, the number of compounding periods. So we've converted this to IS, which is $15 per month here. IS is 1.5% per month. And what we can do here is indicate that this is equal to 60, the annuity, $60 per month. What is F? We know A, the annuity. I is, we've calculated that at 1.5%, and N is at 36. So if we can turn to our tables and get a factor for that, then we're going to be okay, and we'll just conclude it with a simple multiplication. Can we do that? And the answer to that is no. And why is it no? Anybody tell me? No, 36. We don't have an N at 36, but we do have an N for 35 in the table, and we do have an N for 40 in the table. So let's calculate the factors for those two situations, and then we will use linear interpolation for between those numbers for 36 months. So the way I set that up is that if N equals 35, that's months, the factor, I'll just call it that, the factor will equal, and if you go to your tables for that column, FAIN, that will be equal to 45.592. If N is equal to 40, factor will be equal to 54.268. So if we know this, 35 gives us a factor, 40 gives us a factor. The question will be is, what will that factor be if it's only 36? So we're going to use linear interpolation to solve that. So what I'll do here is set up a small chart for this. Won't be too elaborate. So what I can say here then, using that equation, x1 right here, the factor, and we're looking for the factor. That's the unknown. We're trying to figure out what is the factor for 36. So we're going to put our unknown on the x-axis. And that factor is, for x1, is 45.592, and that corresponds to 35 months.
Can you move the paper up a little bit?
You bet. Thank you for pointing that out. X2, we'll put that over here. X2, the factor here is 54.268, and its corresponding value is going to be for 40 months. But what we're looking for is, and maybe I could put this in here, this here would be Y2 to keep the corresponding X2, and Y1. So what we want to know is Y star equal to 36. What will it be on the calculation to here, which is X star? And that's our unknown. So by using linear interpolation, we can solve for what n equal to 36 would be. And once we have that, we can then use that back in this formula here, the factor formula, for solution. But first we have to get there. So our formula is X star is going to be equal to it's going to be equal to X1 plus, on brackets, X2 minus X1 onto Y star minus Y1 and Y2 minus Y1. So putting our values in there for what is to solve for X star, we know X1 here is going to be equal to, trying to keep this not so messy, 45.592 plus 54.268 minus 45.592 onto Y star, which is what we're which is the factor we're looking for, the corresponding factor for Y star. So it's going to be 36 minus Y1, 35, over Y2, which is 40, minus the 35 for Y1. And if you do that arithmetic, you should end up with X star equal to 47.3272. So we can now take that, and it goes back to our equation here. Okay, again, I'll leave it to you to do this arithmetic to arrive at that number. It should be correct, but if it's not correct, please tell me so.
Hey, Wayne,
Yeah,
if you're saying it's going to be tight on time for the test, like if we were just to show you x2 minus x1 divided by 5, and then just add that to y1, is that not saying the exact same thing of what you wrote?
well, if you're tight for time, you should probably do it, so you get something for it. But what I would like to see on there would be the layout. It would be my preference, if you will, so that we stay with the course teaching and doing linear interpolation. I recognize you can use proportionality to arrive at the same solution, and but again, in terms of how I allocate the marks, what I'm looking for would be one for the diagram, one for the formula, and one for putting the values in, and then the solution. So if you're not showing me this information here, then it's going to be difficult for me to award marks for it. So I'm not saying you're wrong by doing it. And if you're tight for time, yeah, because you'll get something for it. I won't mark it all wrong, but those are the key things that I'll be looking for in that portion of the question. So I'm going to copy this formula down here again, just so that we stay in the context. So we know that F will be equal to 60 onto FA 1.5 36. And we know now that FA 1.5 36 is equal to what we just calculated, 47.3272, which should give us an answer then of $2,839.63. So that is a method when you do not have the n value you want from the tables. You could use linear interpolation. Now, linear interpolation, because you are using a straight line to approximate a segment of a curved line, your answer will not be exact. It is an approximation. So ideally, you would probably want to use, like we did the question before, the prime formula. And from that prime formula, you would want to solve for, you need to solve for n. You need to come out of it with this factor somehow. And that will be, I won't say that challenging arithmetically, but the smarter route to go sometimes is to utilize linear interpolation. So if you do not have an n value, and as far as that goes, if you do not have an I value, and that will occur to some of our questions, then you're going to have to solve it by linear interpolation. Normally, if I indicate in the question your solution must include linear interpolation, then this is what I'll be looking for. But it's a segment of the overall solution. Now, if this were instead of 15, and the question might be that she would have, well, wow, I can't make that trip. There's not enough money there. $2,839 will not give me enough money to make that trip. So the next part of the question, I'm just looking for it here now. How about if she actually set aside $20 per week? Well, if it were that, we could use the same approach, but we already calculated what the n value, the factor would be for n equal 36. So we don't have to go through all of this again. all we'd have to do is go back to our formula here, and we would say then F would be equal to the annuity onto FAIN, which you've already calculated from the linear interpolation. But if it's now, what's the number she gave us here? $20 per week. So 4 weeks in the month, that would be $80. So A will be $80 per month. FAIN is the factor we just calculated. And that multiplication should give us $3,786.17. So that might meet her needs more, if you will, but she's going to have to up her deposit from $15 per week to $20 per week. But because, again, we work it at the monthly level, so, and we make the assumption that there are 4 weeks in the month on balance, this is what she would end up with. So she would now increase in the bank. Now this money is still in the bank right here. There's nothing about taking it out. So she would have it in the bank, and maybe at the, the following week, she'd go out and get her airplane tickets and set that up, and then to leave the money in the bank, some of it anyway, for when she's actually touring and having to buy room and board along the way. So that's how that question would be resolved. And the point of it was to use linear interpolation as described in the textbook. Okay. Yes, you're correct. You will be short. And I don't disagree with you. I can only answer that by saying that is how the authors of the textbook have set up this solution. I'm not going to disagree with you on that, Cole. You're correct. You may be a little bit short because there's more than 4 weeks in a month on balance. I guess you'd conclude that. I can only tell you, I don't have a good answer for you. That's why I'm kind of humming and hawing on it, because I think you're correct. But the solution offered by the authors is that you make that assumption that there's 4 weeks in the month. Weeks in a month. You could have tried it that way, using 4.33, whatever it is, in terms of that in the month on average. That would be an approach you could try. I'm not going to say you'd be wrong by doing that. You're probably not going to get a question of that ambiguity from me anyway on an exam. I do my best to not have questions, not develop questions that are ambiguous. So because of that assumption of making, someone might say there's 4 weeks in a month, someone else might say there's 4.2 weeks in a month, and someone else might say there's 4.3 in a month. So you're going to get a variation in your answers if you do that. You could also try to do it as one of the other students did it, and I have yet to work it out that way. I've never done it, but I'm going to try it later. And that's simply to solve this by working it as an annuity of putting money in the bank every 15 weeks. But even though you put it in the bank for every $15, I'm sorry, $15 every week, even though you put it in the bank, that's not earning you any money until the month comes to the end. And the key to doing this problem is to try to get everything into the month level, because that's where your I is going to end up. It's going to be equal to right here. So you've got to somehow convert your your years to months, which is pretty easy, and then you've got to convert your your contributions into that bank account at a monthly level, and hence using 4 would be okay, but you could try it with 4.333 if you like, and I'd be curious to see how the answer comes out. It won't agree with what's at the back of the book, and that's kind of, you think, well, did I make a mistake along the way? Probably not, but you won't get the same answer that's in the back of the book, because their answer in the back of the book utilized this assumption right here. They utilized that assumption. Okay. Okay, where am I time-wise? 3:20. We will do a few questions next week as well, but sorry, just taking a minute here to look at the questions that I had laid out for today to do. We didn't do part B to 326, so maybe we should take a look at it as well, but it says find out exactly how much Rinque needs to deposit every week if she wants to save $5,000 in 3 years. So we could lay out a slightly different, now this is another segment, so you've got to work it on a standalone basis. So I'll put this in here then as EOC 3.26 part B. The other one you could say is part A if you like. So in this case, it has some similarities to what we have. It's going to be running for 3 years. Our timeline. So for our cash flow diagram, 3 years. Again, we will calculate it to the monthly level is what we will work with, but we're going to work it slightly in reverse in that we're going to, instead of saying we're going to look for the annuity, which we don't know what it is. So it's going to look something like this. The way I typically divide this up, I would say, well, if this is 3 years, then this would be 1 year, and this would be 2 years, and that would be 3 years. So my annuity might look something like this. I typically, or strictly speaking, it should start at the beginning of the annuity, and it runs to the end of the first year of the annuity. So it's a little more flattened out here. So if that's the case, we want to know what would be the annuity. We're solving for A. A is the kind of the unknown here. And again, we want at this level to have $5,000. That'll be the future value. So we need the formula that will link us between the annuity and the future value. And that is done using the sinking fund factor, or if you like, it would be done with A, the annuity will equal to the future value, onto A F I N. So once again, we have the problem again, 36 months. We don't have a table for that. Now you could run that same course that you just did, or alternatively, you could use the prime formula to be substituted in here. That would be equal to, I'll put it over here, would be equal to F onto I over 1 plus I to the power of N minus 1. That's the sinking fund formula. So let's just solve for I in that, sorry, for A in this case. Again, we should be able to calculate this. The annuity will be equal to $5,000. That's what we want for the future. Whoops, wrong place for that. Will be, it's not equal swing. Interest rate, we haven't solved for that, so we're going to back up a little bit here. This is the cash flow diagram, by the way. IS at the monthly level will be equal to R over M, just like before, 18% over M, which is 12, the number of sub-periods, if you will, in the year, which means our interest rate is going to be 1.5%. So we can put this in here. I will be equal to, and we need to turn it into decimals, so 0.015 over bracket 1 plus 0.015 to the power of n. N is 36 minus 1. And if you do that, you can work your way through the arithmetic, and you should end up then with A equal to, the annuity will be $105 and 76 cents per month. We've been working at the month level, so the annuity will be monthly. However, the question said weekly, so that would mean it would be equal to 105.76 over 4. Made that assumption again, which in turn is equal to $26.44 per week is what she would have to do. So in that context, we've just reversed it. Instead of looking for what the future value would be, we're setting it as a target and we're solving for the annuity in order to set it aside. So these two, part A and part B, are just working in one case, we're moving from get the piece of paper. In one case, we're moving from an annuity into the future value. And in the other case, we're moving from a future value into the annuity. So it's just the opposite in direction. And that's how you go about solving that particular aspect of this question here. Okay, that takes care of that and that. 3B. Let me just take a look at that one. What about 311? I'm going to try 311 with you. I'm jumping ahead of my schedule here in terms of what I laid out to do for today, or do. The rest we'll do next week, but I think it might be important to maybe do one of these questions, and then I'll come back to the others as well. So I'm going to look at EOC 3.11. Okay. So 3.10 is what we're 3.11 is what we're going to do. So it's a little different layout, and I want to show you how we approach it. So 3.11 is right here. Reginald is expecting steady growth of 10% per year in profits from his new company. All profits are going to be invested at 20% interest. If profits for this year at the end of the year is going to be $10,000, how much will he save after 10 years? So we've got two interest rates we're seeing in this type of question. One is the growth rate. In other words, he's expanding his business. He anticipates he's going to have more customers from one way or another, maybe by broadening his area of operation to include people further away. Maybe there's a population increase he anticipates in this area, new people coming in. But either way, he anticipates that the growth of his company will be 10% per year in profits. And this is all from his new company. Maybe he's opened up a company that's on the other side of the street of someone doing similar type of services, and he feels over time he can draw the customers away from the competitor to his operation, increasing his business at a rate of 10% per year. So when we're doing this, we need our cash flow diagram. So I'll start out here. And again, what he's going to be doing here is he's investing the money into some financial vehicle, and that is $10,000 is what it is. And how much will he have at the end of 10 years? He's going to be investing at 20% interest. So we have to distinguish here between the interest rate and the growth rate. Those are two separate numbers. So let's just set this up here. We're going to have something that covers 10 years. $10 will be his focus. And in the first year, he's going to be making $10,000 profit is what he anticipates. So that's an annuity in a sense. It's not quite true. But let me set this up first and I'll talk more about it. So again, he's investing the profits. So that's money leaving him. It's a disbursement. It's his money. He's investing it into some sort of investment opportunity, but he's given it for someone else to have for the time being on the basis that in the end it comes back to him. But in the interim, it's no longer his money. So what we have there is $10,000 per year is how we can look at this. $10,000 per year. But every year that goes beyond, that goes further in time, it's going to increase in growth by 10%. So when we see that, remember we talked about gradients? Well, if the gradient is linear, you're going to have a arithmetic gradient factor to work out. If it is exponential or nonlinear, you're going to have to work out a geometric gradient factor. Unfortunately, we don't have tables in the case of this type of scenario. There's no tables at all. That doesn't mean they can't be generated, but the book does not provide that. So what I'm going to do here is show you how this must be represented. So what we're saying here is that with every passing year, he's going to grow by 10% over the previous year. So if you were to draw this, and my freehand is not normally good, it won't be a straight line because it's geometric. If it were a flat amount, it would be a straight line, but this is a percentage. So this is going to look something like, it's a curved line. And G in this case is going to be equal to 10%. That's his growth rate, small g. The interest rate that we're being given is equal to 20% per year. So that's not compounded. It's just flat out, that's how much he is going to earn on his money, on his investment. 20%. There's no compounding at all. So 20% is your interest rate, that's I. So the first thing you have to do when you're calculating a problem of this nature is to figure out what's called the adjusted, I'll word that better, the growth adjusted interest rate. So the growth adjusted interest rate, and it will be equal to, first of all, it's designated by I naught. That's in the formulas that you've probably looked at already. And it is equal to 1 plus the interest rate over 1 plus the growth rate minus 1. So we know that the interest rate is 20%. So that will be equal to 1 plus 0.2 over the growth rate, 1 plus 0.1, representing 10%, the numerator representing 20% growth rate, minus 1. So if we work that out, you should end up with 0.09090909, and maybe more, or you could express it as 0.09, these two numbers reoccurring. Again, whenever you're using any interest rate, carry at least 4 or 5 decimals of a percent, not of the decimal, but of a percent. Otherwise, the amount that you truncate off may have an accumulative effect on your answer. So now that we have that, we can go back to the formula here. So we know then that the formula for working with a geometrical gradient series is you can calculate the present value by looking at A, the annuity, which is your base of your gradient. The gradient will have a base. That's an annuity. But it's going to have what is P, if we know the annuity, G, the gradient, the growth rate, I is the interest rate, and N. That's using a factor statement, but we don't have those values calculated for us. So what we can do here is go on and put the equivalent of this as which is the prime formula for it. So this will become the annuity onto 1 plus I, the interest rate, but it's the growth adjusted interest rate, I naught to the power of n minus 1 over I naught onto 1 plus I naught to the power of n to be multiplied by 1 over 1 plus g. Now that's a given formula. You should be able to find that in your formula sheets. And it's also in the textbook. It's in the back of the textbook. And as I mentioned to you before, there are formula sheets or lists of formulas, I'm not sure how they call it, that's been published, and I have copied that and put it into Learn for you to make it more, which is exactly what's in the back of the textbook. So that would give us, and a key thing to remember here is that whenever you're using the geometrical gradient series formula, it will give you a present value. That's important to remember for the next step in this question. So let's put some values in here. P, the present value based on that formula, will be equal to the annuity, which is 10,000. That's the base of the gradient, the geometric gradient, onto 1 plus 0.09 reoccurring to the power of n, which is 10 years, minus 1, this is a 10 by the way, over, using this formula here, 0.09 reoccurring onto 1, whoops, it's not a 1, onto 1 plus 0.09 reoccurring to the power of n, all to be multiplied by 1 over 1 plus g. G is 10%, so 0.1 or 10, whichever way you want to put it. And if you do that arithmetic, which is fairly straightforward, you should find out then that P will be equal to $58,110. So that would be the present value, the equivalent present value of his next 10 years of projections using a geometric gradient series. But the question asked, when you look at it, how much will he save, will be saved at the end of 10 years? So then we'd have to take this value and we'd have to determine its equivalent amount 10 years into the future. So that part would be here. Just have enough space here. I'm going to rub that out. So the future value will be equal to the present value onto what is F, if we know P, I, and N. P is the present value which comes to us from the geometrical gradient series. Don't lose track of that when you're using the geometrical gradient series, it will calculate for you the present value, which may be what you're looking for, or in this case, not. You're looking for a future value, but to get to the future value, you have to go through the present value. So it is a sort of a bit of a maneuver you have to take into account. So P in this case would be the 58,110 onto what is F. If I know that P, I is the interest rate, 20%. and N is, it's 20% per year, and the N is 10. So hopefully we have a table where I equals 20 and N equals 10 within that table, and we do. So what we can do here is simply say 58, 110 onto the factor, which you can extract from that table for the in this case, the interest rate for the I value. And what you would have here is 6.1917. And multiplying that out would indicate that you will have, after 10 years, or who is it? Reginald will have $359,000 plus 800 more. So $359,800 is what he would have under that scenario of being able to anticipate a geometrical growth of 10%. And in also a part of that scenario is that he can invest his money at 20%. If that's the case, this is what he'd end up with. The future value of that 10-year scenario will give him in the end $359,800 in the bank account. So that's how you go about that. This is one of the situations that I can share with you and indicate that we cannot, in the first instance here, we cannot, there's no tables. So you have to use the formulas which are given here. If you're doing this, you wouldn't need to show, I won't mark it out, but you wouldn't need to show this portion of it. You can go directly P is equal to this. That's quite okay, because that's the formula you have, although it is in the textbook as well, the formula sheets. Keep in mind here, do not, if you're putting in this number, put 09, sorry, I'll try that again, put 0.09090909 into your calculator. If you don't, you would be dropping 0.1% over each year of calculation. If you simply said, well, I'm just going to call it 9% or 0.09, you're dropping the influence of this. And with every additional number, you're propagating a higher and higher miscalculation in your work. So once again, when dealing with an interest rate, especially an interest rate, when you're as an interim step to your final answer, do not truncate that at a convenient number, because I've seen people work this as, well, again, I don't want to mess up my work here, but they'll just simply say, well, let's just call it 0.09 or 9%, and I'll go on from there. Well, the difference between that and 09 reoccurring, or maybe I could say, 09 reoccurring is significant in this question. You will not end up with this number, and you will not end up with this number, because it's 0.1%. That's what it translates into. You're essentially dropping the effect of all of these last four digits. So do not truncate prematurely or round off prematurely when dealing with an interest rate, unless that is your final answer. Then you can say, well, 9.1 or works. But that's the case in the event of a, that's what you're looking for. That's your final answer. But in the case here, the growth adjusted interest rate is really an interim step to determine the present value, which in turn is used to calculate the future value. So an error in the interest rate or a shortfall of the interest rate will propagate through the question, creating a wrong answer. So again, I know I'm repeating it for probably about the fourth or fifth time. Please don't do that, because again, you'll lose points for doing it. You may get some points because you're showing me you know how to go about it, but you should not truncate or round off an interest rate at a convenient level to save a little bit of handwriting on the exam or something of that nature. Okay, on that. So that's 311. Be done. Where am I time-wise here? For comparison's sake, it's not on my list, but I'm going to back up here and do 310 now for comparison's sake, because it's, again, a different layout. So for question EOC 310, we have a situation where there's the lottery question. Maybe I won't do 310. The reason being is that it is a bit convoluted, and I would not ask that type of question on the exam. So I won't do 310. That's why I don't have it on my list, I now realize. So I'm not going to do 310. What else do we have in here? Let me go to question 3B. What's 3B about? This is supplementary. So let's take a look at that one there. 3B, go to your supplementary questions. It's a tensile compression tester, secondhand, that costs $17,000. It can be financed at 5.9% with monthly compounding for 48 months. How much will the monthly payments be? So this is a typical question, matter of cash flow. If I'm buying something and I'm going to have to pay an interest rate, how much is that going to cost me per month? So let's take a look at that particular question here. And we need a this scenario here. Need our timeline, our cash flow diagram. And we are going to indicate here we need to look at this from the purchasers or the buyer's perspective. So he has gone to the bank and borrowed $17,000. So the bank has given him this money at a rate that he's going to have to return. So that's going to be a receipt because the money's coming from the bank to him from his perspective. And in return, though, he's got to pay that money back to the bank. So 17,000 is what you have here. That's what you now have as cash inflow. But now that you have that cash inflow, you got to pay the money back to the bank, as I mentioned. And the question is, you want to pay it back in 48 months. Four years, in other words. Now, your interest rate that you've been given here, I is equal to 5.9% with monthly compounding That's the wording in the question, so I'm going to stay with it. So that's compound it monthly, just a different way of saying the same thing. So we're going to use the capital recovery factor to solve this. We know that IS will be equal to R over M. This is a nominal rate of interest. It's compounded. So it's going to be, I'll leave it in a percentage for the moment, 5.9% divided by number of months in a year, 12 of them. So our sub-period interest rate is going to be equal to 0.004916 reoccurring. And we could express that as a percentage, but it doesn't make a lot of sense because we're going to have to use, we know right away we don't have an interest table for 4.9. That's a given. We know that now. For 0.49, I'm sorry, per month. It just don't have it. So I'm going to leave it that way because we're going to have to use prime formulas. So in this case here, we're going to say we're looking for A. What is A here? A is our unknown. How much do we have to pay the bank back every month in order to offset that loan they gave us for $17,000 to buy this this tensile tester? Okay, so we know here that A, the annuity, that's what we're looking for. How much per month are we going to have to pay back on a regular basis? X dollars per month, X dollars per month, X dollars per month for 48 months to pay this off. And we're working at the monthly level because we've set that up as part of the agreement with the loan that it'll be paid off in 4 years or 48 months. So we know the present value. So the question here is, what is that annuity if we know P, I, and N? Unfortunately, we don't have tables to use in this case. The I value, we just don't have an I value equal to, where am I here, 0.4916. What I've seen some students do, and please don't do this, they'd say, well, that's close enough. Let's just call it 0.5%. And I have a table for that, so I can use it. That will get you a wrong answer, not by a lot, but it is not the correct way to do it. Because you're then ignoring the difference between this value and 0.005000. You're ignoring that difference, and you can't do that. So we're going to have to use the formula here. We know that P is the present value. We have, for this, we're using the capital recovery factor to do this. It's going to be I onto 1 plus I to the power of N over 1 plus I, the power of N minus 1, and a bracket. Putting numbers into that, the present value is $17,000. Working from here, I, we've calculated that here, so it's going to be 0.004916, the 6 is reoccurring, onto 1 plus 0.004916, that part's reoccurring, to the power of N. N is 48. In the denominator, we're going to have 1 plus I, 0. don't have enough zeros in here. I'll correct that in a minute. 004916. Maybe just because you're following along here, I'm just going to restate that here so it's not incorrect. Zero point 004916. The 6 is reoccurring. And down here we have this to the power of n minus 1. So if we do that arithmetic, I said n here, and I should put the actual number in here, 48. If you do that arithmetic, you should end up with $398.47 per month. So that is how much you would be paying the bank back for that $17,000, which was the money you needed to buy that piece of equipment. Okay. So again, if I were marking this, you'd get 1 for the diagram, 1 for the calculation of an IS, because you needed it. You couldn't work with the nominal rate. 1 for the formulas here, 1 for putting the correct numbers into the formulas, and then 1 for here. Normally, as you'll see, and I'm going to go over it with you next week as to how you should lay your questions out to accumulate the marks. You should always start out with your prime formula, your factor formula, and then if you can use it, proceed. If you can't use it, you have to substitute in the prime formula. So that would be worth 1, 2, 3, 4, 5, 6 marks to do that amount of work right there. Is how I would set that up to be marked. So I will go over with you in the next lecture, and you should take a look at it already. It's in Learn, and it's what I call my rubric, and that's my guideline. It is a guideline I use for marking. So you need to be somewhat aware of that and following it closely, because that's how you're going to achieve your marks along the way. If you're following my paper here and writing it down, remember here I changed my mind on this. This was the supplementary. And it was supplementary 3B. So that should straighten that out. And that's how you proceed with that one. So that's all I have for today. But like I say, next week we'll go over that marking guideline that I use. I will also set up here for, what did I say? I just want to look at that. Where are you? I'll set it up for 11:30. And it'll last for 1/2 of an hour. Your viewing of the results from quiz number 2. That'll show you your correct answers, and it will show you your if it's wrong and different, it'll show you your answer versus the correct answer for those quiz questions. So I'll send out an email to that effect right away so people know it. And then I'll open it up here. It takes me a couple of minutes to set the terms for seeing that now. And hopefully that works out well. Otherwise, I'm pretty well done for today on this. So if you like, I'm going to stop sharing. I'm going to stop, first of all, sharing, as I say here. Where are you?